Many people now compare the digital transformation with earlier industrial transformations, which were propelled by general purpose technologies like steam or electricity. Whether we call it a second machine age, the third wave, society 5.0, or industry 4.0, significant changes are definitely underway. For example, by 2025, it's estimated that about 30 billion devices in home and in our workplaces will be equipped with sensors, processors, and embedded software, all connected to the Internet of Things. Digital transformation affects all countries across the globe, so not only those inside the Danube region. And its importance is underscored also by the United Nations Sustainable Development Goals.
Inventions are typically seen as new combinations of new or existing knowledge, but if we truly want to talk about innovation, they need to at least be subject to attempts at commercialization. In that sense, the innovation is also intrinsically connected to the ability to take advantage of the opportunities related to the innovation, hence being entrepreneurial. And both innovation and entrepreneurship have similar attributes. Firstly, they're all both dealing with newness. Example, patents can only be granted for new and inventive inventions. And in entrepreneurship, we want to take advantage of novel combinations of resources. They both also deal with high level of risks, as well as they require the additional knowledge on which inventions are relevant, or in entrepreneurship, we would be talking of opportunity spotting. There are different types of innovation. Typically, what we contrast are technological versus non-technological innovations, such as organizational innovation, innovation in business models, marketing innovations, more recently also social innovations. We will focus more on the technological innovation. These can be either product or they can be process innovations. In terms of their impact, they can be radical or disruptive, or they can be incremental or sustaining innovations. Several trends have also put emphasis on particular types of innovations, such as eco-innovations or circular innovations. However, then, regarding the type of technology, what we will focus on are the digital innovations. If we build up on one of our previous slides and go from innovation to digital innovation, we can see that digital innovations would be product or business process innovations that contain information and communication technologies or IT technologies, as well as innovations that rely to a significant degree on IT for their development or their implementation. And similarly, so if we would talk about digital entrepreneurship, it's all about creating either new ventures or transforming existing businesses by developing novel digital technologies or novel usage of these digital technologies. So what you can see left and right is this emphasis on IT technologies or digital technologies. So we will look a little bit more into that in the next slides. The digital technology that has become so widespread in recent decades has two complementary elements. each dependent on the other. First, hardware refers to the physical components such as the microprocessor chips inside a computer, as well as any external devices that the computers are able to control. Software, on the other hand, includes all the protocols and instructions to tell the hardware what to do, when, and how. They are typically complementary, but we will take a look a little bit more on the types of these digital technologies. Let's take a look at some of these digital technology types. Big data refers to large and diverse sets of information to store, manage, and analyze a high variety, volume, and velocity of data. So very much connected also to big data analytics. And one of the things or one of the concepts often talked about is also knowledge engineering, which is a field of artificial intelligence that basically creates rules to apply to data to imitate the thought process of a human expert. But artificial intelligence is more. It's not just the processes, including learning, which these rules for using information are part of, but also reasoning, so using rules to reach some kind of conclusions. And additionally, some add to that also the self-correction. Also other types, sensors as a hardware, robotics, automatization as a process. One of the wide areas is the Internet of Things, and tech trends for 2021 still regard IoT applications as one of the top trends, which have been supported also by the need for location independence, especially during these COVID times. Another type is the additive manufacturing, which we know more under the name 3D printing. And there's a variety of processes and machinery, so both hardware and software related to 3D printing in relation to a variety of materials from plastics to metal and cement, all with particular issues that are still to be solved by more innovation, as well as ideas such as are we using virgin, are we using non-virgin materials. If we look at them through the patent numbers, what we can see is that this is an area that is being more and more interesting. And especially it's being more and more interesting to not so much to research institutes anymore, but basically to companies. Also, one of the things that one can see is that at the beginning, a lot of innovation was related to additive manufacturing processes themselves, but now there's a broad range of innovations related to it, from data acquisition, right, to controls, etc. To blockchain, which was important first in the financial sectors, but now relevant to various other sectors such as logistics. Also, if we think about it, important to other trends today, such as sustainability or circularity. And if we think about the combination of innovation and entrepreneurship, we can think of a startup that's offering new, more sustainable solutions, such as example, leather from fish skin. And at the same time, they're also integrating as part of their business offering or as part of their business model the typically IT supported traceability of their ladder, and that is through using blockchain solutions. Industry 4.0 is becoming a very significant concept in many sectors. It refers to connectivity of machines and persons via real-time data. So, for example, machines connected to a robot, those connected to the sensors, connected to internet, and then everything can be operated automatically to optimize the processes. So what we can do with it is enable automatization and production, as well as optimize performance of production, as well as product design, of logistics, and other processes. What we're going to do now is take a look at kind of the evolvement of digitalization and see how it all fits together.
We could divide the evolution of the digitalization in three phases. Phase one would be the digitalization of the machine itself, and connected to that would be also the first, let's say, sector and its technology fields. And these are the core technologies, the hardware, the software, the connectivity, which basically transform any object into a smart and connected device. Phase two is digitalization of the machine environment. Connected with these are enabling technologies such as analytics, security, artificial intelligence, position determination, power supplies, 3D systems, user interfaces. So in general, they are used in combination with connected objects. The third phase, however, is digitalization of the ecosystem. We could say the kind of the final frontier. Here we talk about application domains such as home, personal, enterprise, infrastructure, vehicles, etc. These allow the potential of the connected objects to be exploited. So in turn with this development, the patenting is also following. We can look here at the number of patents in the so-called fourth industrial revolution, and we can see there is a steep increase of the patenting in the last 2-3 decades. In the automotive sector, the rapid developments in digital technologies are reshaping vehicle innovations, example, car connectivity, autonomous driving, innovations in the production with smart factories or Industry 4.0 applications, as well as the influence new business models. When we think about technology supporting the after-sales services or expansions into on-demand mobility services. the automotive sector is, of course, not immune to the potential of the new digital innovation. And indeed, we can both connect the four usually enumerated disruptive trends in the automotive sector: the electrification, digitalization, autonomous driving, and shared driving, with software solutions, but also the new shift towards more sustainable and circular solutions in the automotive industry, again, are strongly connected to digital solutions and software and so-called software patents. And indeed, if we would break it down to different technical solutions, example, those connected to autonomous driving patents, we would see there is an increase of this patenting within the years, so from 2001 here to 2018. So the shifts in automotive are not only connected to new companies, new types of companies entering the automotive industry, but sometimes we can be surprised when we look at portfolios of very traditional actors in the automotive industry. This is, for example, the patent portfolio for the General Motors. And one thing that you can see is that some of the positions in the what they call the total technology space are very connected to digital solutions, right? You have the electric communication, computing, and electric elements, for example. So what that actually means in the end, that the General Motors is basically, in terms of their portfolio, more proximate with some telecommunication firms than other automotive firms. For example, here, if you look at its proximity to Ford Motor as opposed to Huawei, you can actually see that their portfolio is closer to Huawei or to Ericsson than it is to more traditional Ford Motors, Nissan, Toyota, or even Tesla motors. So there are shifts happening everywhere inside of the automotive industry.
If we think about the effects of digital innovation on entrepreneurial activities, we can see that they shift both the processes, right? How, when entrepreneurial activities are implemented, how flexible, how agile parts of the processes are, as well as the entrepreneurial outcomes, right? There's many new opportunities arising. There's a positive outcome on the scaling up on the scopes, as well as on markets of product and service offerings.
So emerging from the nature of the digital objects, there are also shifts in how we think about managing the digital IP and how we manage it in reality. So digital inventing is different, and those who master it develop patent portfolio along use cases, and we'll talk about this in just a moment, like developing software along architectures. The way, the approach on how we create digital invention is also slightly different. There's a joint approach among the creative and IP part. That's not to say that the IP part isn't creative. But they jointly create, on purpose, a digital object that is patentable. So it's not a classical waterfall or stage gate process. Digital inventions are also different, and so are digital patents. Digital inventions are more abstract, they're broader, they're more aligned with the business model and the use case, and are not only based on the classic technicality or a technical solution. Therefore, also the related patents are different, right? They would be more abstract, they would not come from physical reality or technical functionality, but rather from the application, the solution, the use case. That, however, sometimes tends to be a problem in terms of patenting and the patent application itself, because not only do you need a technical solution to patent, you also need a technical problem. And again, we'll talk about this in one of the next segments. There are interesting shifts in patenting digital solutions or patenting computer implemented inventions. So that can be either methods performed on a generic computers, or methods that require some specific means, or methods implemented in a distributed environment. But sometimes or many times we simply call these software patents, patenting software. What we need to take into account is that not only the solution needs to be technical, but also the problem must be technical. when framing the patent. So you either need to take this into account from the beginning on, or you must be able to pivot and thus reformulate the problem statement inside the patent at a later stage. One also needs to understand the difference between technical and non-technical features and be cognizant of the fact that the problematic step in the patent process isn't really one of statutory matter, because basically only one technical feature will save you there, but the problem part is that of the inventive step barrier. Thank you for taking part into this, taking part of this software patent session of the Knowing IPR training. Feel free to contact me via email should you wish to continue the discussion. Thank you.